Good day, class. Welcome again to our General Chemistry 2 class. So for this video, we're going to discuss about properties of liquids. For the objective, describe the following properties of liquids and explain the effect of intermolecular forces on these properties: surface tension, viscosity, vapor pressure, boiling point, and molar heat of vaporization. In the last video, we distinguished among the three states of matter in the light of the kinetic molecular theory. So we distinguished them in terms of properties such as volume, density, spaces between particles, and forces. We also discussed the different intermolecular forces, the forces that are responsible for the formation of the different states of matter. So we have the dispersion or London forces, the weakest of all intermolecular forces, which exist in nonpolar molecules, the dipole-dipole forces in polar molecules, ion-dipole forces between ion and polar molecules, and hydrogen bond, the special dipole-dipole forces that exist between hydrogen of one molecule and an electronegative fluorine, nitrogen, or oxygen of another molecule, and which is also strongest among the four intermolecular forces. So as a review, let's determine the type of intermolecular forces between the molecules of the following substances. Number one, benzene. Benzene is a nonpolar substance or molecule. So for nonpolar molecules, it's exclusively dispersion. Dispersion is a result of polarizability of molecules. Polarizability is the ease to distort a molecule. So nonpolar molecules are highly uh, polarizable. That's why dispersion, which is also the weakest of all the intermolecular forces, exists between the molecules. Chloromethane or methyl chloride is a polar molecule. So definitely it's a dipole-dipole because for polar molecules, the type of intermolecular force is dipole-dipole. But since dispersion is a result of polarizability of molecules, dispersion also exists in all molecules, between all molecules. So dispersion is another type of intermolecular forces that exist between chloromethane molecules. Another is phosphorus trifluoride. Phosphorus trifluoride, like number 2, is also a polar molecule and therefore another dipole-dipole. But again, dispersion exists in all types of particles and therefore dispersion is another IMF between the particles of the substance. Sodium chloride, it's dispersion, again dispersion and ionic. And carbon disulfide is nonpolar and therefore dispersion. What about between the following substances? Hydrogen bromide and hydrogen sulfide are both polar. So therefore, between them, it's dipole-dipole. But again, dispersion exists in all types of molecules or particles, and therefore dispersion is also existing between the particles of the substances. Number 2 is diatomic molecule chlorine and carbon tetrabromide. Both are highly polarizable, both are nonpolar, and therefore exclusively dispersion. Another diatomic molecule, iodine, and an ion nitrate. So this is ion-induced dipole dispersion. Induced dipole because the neighboring ion will cause the nonpolar iodine molecule to be induced, to become an induced dipole, and therefore the type of force is ion-induced dipole and also dispersion. Another is ammonia and benzene. Ammonia is polar, benzene is non-polar, and therefore dipole because benzene being a non-polar is highly polarizable. The dipole molecule ammonia will cause benzene to be an induced dipole, and therefore it will become dipole, induced dipole, or simply dipole-dipole and dispersion. To continue, let's try the following. What type of intermolecular force exists between molecules or basic units in each of the following substances? Number 1, water; 2, ethanol; and 3, oil. So in order to determine the type of intermolecular force, you have to be able to identify the substance as either nonpolar or polar. Again, if it's nonpolar, definitely it's London forces or dispersion, the weakest of all intermolecular forces. If it's polar, then dipole-dipole. If it has hydrogen and nitrogen, fluorine, and oxygen attraction or bonding, then a special dipole-dipole, which is hydrogen bonding. And if there is presence of ion and another dipole, or highly polarizable nonpolar, then it will be ion-induced dipole or simply ion-dipole forces. So it depends on the type of intermolecular uh, uh, it depends on the polarity of the molecule. You can determine the type of intermolecular force between the particles. Number 1, water. Water has hydrogen, oxygen atoms in each molecule. So since there is hydrogen and oxygen, a hydrogen bond is exclusive with oxygen, nitrogen, and fluorine. So hydrogen bond is a result of the attraction between hydrogen of one molecule of water with oxygen of another molecule of water. So that bonding between hydrogen and oxygen of another molecule is called the hydrogen bond, a stronger dipole-dipole force. Ethanol also has oxygen in the molecule. So it also is possible to form a hydrogen bond between oxygen of one molecule of ethanol and hydrogen of another molecule of ethanol. So this is another hydrogen bonding or hydrogen bond. And another oil with the general equation C sub n H sub n O sub n. This is a nonpolar molecule and therefore dispersion. So again, it depends on the type of molecule, whether polar or nonpolar. You can tell or identify the type of intermolecular force. For another exercise, let's have the following terms. These terms are either the properties or associated with the properties of liquids. So again, our topic in this video is properties of liquids. So I'm going to show you some images. You associate the following terms with each of the images. Number 1, we have this picture. So which terms can be associated with the picture? So it can be liquid. Yes, we can also associate vaporization because you see formation of gas. We can also associate density because you have fluid and solid. We can also associate volatility for as long as you have liquid. What else? Sublimation, because solid seems to turn to gas. Freezing, because this seems to be a frozen liquid. And melting, because this is a frozen liquid, it may be assumed to be melting. Another is this apple. So we can associate liquid because you see beads of liquid on the surface of the apple. We can also associate surface tension if you know what explains the formation of beads on the surface. We can also associate density, yeah, and okay, we have liquid here. We have melting, freezing, density, of course, volatility as well. We can also associate vaporization. We can associate here liquid, viscosity, boiling point, density, volatility also, melting, freezing also. So almost all the terms can be associated with each of the images that were shown. Let's now define a liquid. What is a liquid? A liquid may be defined as a state of matter with definite volume, low density, takes the shape of its container, whose particles are close together and are incompressible. Because of the limited spaces between particles, they are incompressible. Particles are also in random. They are not closely packed. The container also contains the molecules because of the loose attraction. Particles may have the ability to flow and break away from the attraction. What else? Whatever the volume of the container, the shape of the container, they will be taken by the liquid. So those are some of the characteristics of liquids as shown in this illustration. Now, what are the properties of a liquid? Number one is surface tension. What is surface tension? It is the measure of the amount of energy required to stretch or increase the surface of a liquid by a unit area. For example, by 1 centimeter by 1 square centimeter. It can also be defined as the resistance of a liquid to increase its surface area. So the more resistant a liquid is to stretch its surface area, the higher its surface tension. So we have here the following images. So number one, you see a water strider being able to walk on water. Water has oxygen and hydrogen. So the type of intermolecular forces is a strong IMF, which is hydrogen bond. Since there is a strong attraction, intermolecular attraction between water molecules, it is not easy to increase the surface. So it requires higher energy to increase the surface area. And dahil din sa hindi naman mabigat yung mga insects, or for example in this image, the water strider, the weight of the insect or this animal is not sufficient enough to break the chemical bond that exists between the water molecules. So the water is resistant to increase in its surface area. So that's the reason why insects are able to walk over the water or some other liquids. Surface tension is the reason. Another is the formation of water beads on an apple, which has a waxy surface. So again, apple has a waxy surface since wax as or maybe assumed as oil is insoluble in water. They have a different polarity. Okay, water is polar, oil is non-polar, so they will not mix together. So that's the reason why water here forms beads, because water molecules at the surface of a liquid are being pulled towards inward rather. Water molecules are being pulled inward by molecules below the surface, below the surface molecules. That's why water molecules tend to form beads on the surface of a waxy apple. Okay, so that's what makes the water molecules form beads on the surface of the apple. Okay, we have here two liquids. Letter A is water and B is liquid mercury. So as you can see, by capillary action, there's rising of the liquid in the narrow tube. But what is the difference between the two? Let's take note of the two forces in the following. We have adhesion and cohesion. Adhesive forces are the attractions between unlike molecules, cohesion between like molecules. So where is cohesion and where is adhesion here? Cohesion is the force between water molecules. Also, cohesion is the force between particles of liquid mercury. So between the like molecules of water and liquid mercury, it's cohesive force. Adhesion is between the water and the glass. It's between the mercury and the glass. So that's adhesion. Unlike attraction between unlike molecules. Notice the meniscus. Meniscus can be concave, like what forms here in water, or convex, as what forms here with mercury. Bakit nagkakaroon ng concave meniscus at convex meniscus? This happens, concave meniscus, as in water, happens when the adhesive force is greater or stronger than the cohesive force, meaning mas mataas yung attraction, mas malakas yung stronger yung attraction between the water and the glass kaysa dun sa attraction between the water molecules. On the other hand, between the molecules of or between the particles of mercury, mas strong yung cohesive force, yung attraction between the mercury particles kaysa dun sa attraction between the glass and the mercury particles. So that's the reason why the meniscus forms convex. Okay? Mas mababa rin yung pag-akyat ng liquid kasi nga mas attracted yung mercury particles dun sa other mercury particles kaysa dun sa glass. Unlike dun sa water, mas malakas yung attraction ng water dun sa glass kaysa sa attraction ng mga water molecules with one another. Another property of liquid is viscosity. Viscosity is the measure of a liquid's resistance to flow. So the more resistant to flow, the higher the viscosity. So it's like the behavior of water, the ability of water to flow, and the ability of oil, for example, to flow when compared. Alam naman natin na mas mabilis mag-flow ang water kesa sa oil. Mas resistant ang oil. Therefore, the more resistant, the higher the viscosity. So we can conclude that oil is more viscous than water. Liquids with strong IMF have higher viscosities than those with weak IMF. Mas malakas yung attraction between particles, mas held strongly sila by themselves. Okay? So mas resistant sila to break away from the attraction and flow. Hindi katulad nung weak yung attraction, mas madaling mag-break away from the bond and mag-flow freely. Also, viscosity decreases when temperature increases. It's like magma. So, kung may imagine natin yung magma, pagkalabas sa crater, mainit, mas mabilis yung flow. Once na nag-cool siya, habang lumalamig siya, mas bumabagal siya. So, increase in temperature decreases viscosity. Decrease in temperature, mas mababa yung temperature, mas malamig, mas mahina, mas mabagal din mag-flow, mas highly viscous. So that's how we refer to viscosity. Let's compare the viscosity of some fluids here. We have acetone and let's have blood. Blood has viscosity of 4 times 10 raised to negative 3 when compared to acetone. If we are going to make use of some typical liquids, halimbawa ang water and alcohol, alam natin na madaling mag-evaporate ang alcohol. Of course, we have established that oil is more viscous than water by observation. Mas mabilis mag-flow ang water. So, less viscous siya kesa sa oil. Oil is more resistant, mas mabagal mag-flow, and therefore higher viscosity. When comparing, for example, acetone and water, same thing, or alcohol and water. Hindi natin iniiwan basta ang alcohol or ang acetone ng open sa air. Kasi alam natin na after some time, mauubos siya. Kasi mas mabilis mag-evaporate kasi mas mahina yung attraction between part, mas mabilis mag-break away from the chemical bond, and therefore mas mabilis siyang mag-flow or mag-break away. So the strength of intermolecular force has something to do with, or viscosity also has something to do with the strength of IM. The stronger the IMF, the intermolecular forces, the more difficult to break away from the chemical bond, the more viscous is the liquid. So comparing blood and acetone, we have blood 4 times 10 raised to negative 3. This is much greater than that of acetone, which is 3.16 times 10 raised to negative 4. The difference in the exponent, negative 4, is smaller than negative 3 of blood. Therefore, blood has higher viscosity than acetone. We also observe na mas malapot talaga ang blood kaysa sa acetone. Di ba meron nga tayong saying na blood is thicker than water. And on that note, mas malapot, in layman's term, mas malapot, mas viscous. So it's like yung phlegm, 'di ba? Pagka nahihirapan tayong ilabas pagka may phlegma tayo kasi masyadong viscous ang phlegm, masyado siyang resistant to flow. It is highly viscous when compared to typical liquids like water, alcohol, or acetone. So that's what we mean by viscosity. Another property of liquid is the molar heat of vaporization. This is defined as the ability or the energy in kilojoules required to vaporize 1 mole or to turn 1 mole of a liquid to gas. Let's arrange the following in order of increasing heat of vaporization. Again, heat of vaporization is the energy necessary to vaporize 1 mole of a liquid. We have argon. Argon is one of the noble gases. So this is a nonpolar molecule. Methane is also nonpolar. Diethyl ether is also nonpolar. Benzene, nonpolar. Ethanol, polar. Water, polar. Mercury, metallic. And iron, also metallic. So in terms of strength of intermolecular forces, you can determine the order of in terms of heat of vaporization. And the answer is this. So parang naka-arrange na siya. So in terms of heat of vaporization, this is increasing from argon to iron. So take note of the strength of intermolecular forces. Sabi nga natin, pag non-polar, weak ang intermolecular forces. The type of IMF is London or dispersion forces, the weakest of all intermolecular forces. Hydrogen bond is strongest, but pag meron kang involved na ionic, syempre stronger ang ionic, much stronger kung metallic. So that what accounts for the order here. Increasing heat of vaporization, the strength of intermolecular forces. As we can see here, we have argon with 6.3 heat of vaporization compared to water 40.79. Argon is nonpolar. Water is polar. So between nonpolar and polar, polar has stronger intermolecular force. So that accounts for the big difference between the heat of vaporization of argon and water. Okay, when molecules escape from the liquid state to form gas or vapor, this is called vaporization. So to vaporize 1 mole is to apply certain amount of energy or the molar heat of vaporization. The process of turning liquid to vapor is vaporization, and vice versa. We have vapor to liquid, we have condensation. Once liquid molecules escape to become vapor, they begin to exert vapor pressure. Vapor pressure is the pressure exerted by a vapor in equilibrium with its liquid. Let's take a look at this illustration. So, meron tayo dito ang container na open. So, what happens when you leave a liquid in an open space after, let's say, several hours or even days? Hindi ba para itong tubig na nag-iwan tayo after 1 week, for example, na umalis tayo, pagbalik natin, wala na. Because even at room temperature, water molecules vaporize. So, dahil hindi naman room temperature is not 0 degrees Celsius. It's between 20 to 30 degrees Celsius. At that point, meron tayong tinatawag na volatility. Hindi kailangan na mainitan to a certain temperature yung liquid bago mag-vaporize. So naturally, molecules escape from the liquid state to become vapor. So yun yung nangyayari kung bakit nagkakaroon ng pagbaba ng level once we leave a liquid in an open space. Kasi water molecules are escaping. Nag-escape, nag-vaporize until such time that all the molecules have escaped the liquid state. On the other hand, kung close naman yung container, kahit nag-vaporize pa siya, hindi siya bababa yung level or hindi mauubos kasi water molecules are escaping pero kumbaga nag-vaporize pero bumabalik din. There is equilibrium between vaporization and condensation in this situation. In connection to vapor pressure, let's have the fourth property of liquid, the boiling point. This is the temperature at which the vapor pressure of a liquid is equal to the external pressure above the liquid. So boiling occurs when vapor pressure equals atmospheric pressure. To reach the atmospheric pressure, heat energy is required by liquid to be absorbed. So comparing the boiling point of, or rather the vapor pressure of the three liquids, water, ethyl alcohol, and ethyl ether, at 100 degrees Celsius, as we know, water it starts to boil. The boiling point of water is 100 degrees Celsius. The vapor pressure of alcohol at that temperature, 100 degrees Celsius, is 760 torr. So 760 torr vapor pressure of water is equal to the atmospheric pressure, 760 torr. At that temperature, the vapor pressure of ethyl alcohol is already at 1693.3, and that of ethyl ether is already at 4859.4. So that's how the vapor pressures of the three differ. So among the three, alin yung pinaka mabilis magbo-boil? Since the atmospheric pressure is 760 torr, mas mabilis mag-boil ang ethyl ether kasi mabilis niyang ma-reach yung same atmospheric pressure. Water requires 100 degrees Celsius para ma-reach na yung 760 torr and boil, while ethyl ether requires much less energy to reach that temperature, to reach that atmospheric pressure, for its vapor pressure to become equal at with the atmospheric pressure and boil. So when you compare the boiling points of the three, alin sa kanila yung pinakamataas? Of course, that of water, at ang pinakamababa ay ang sa ethyl ether. So again, anong relationship ng boiling point, vapor pressure sa intermolecular forces? The stronger the intermolecular forces, the higher the amount of energy required to vaporize. For a liquid to vaporize, we need energy. So the greater amount of energy required to vaporize, the greater the boiling point. So, mas ang pagtaas ng vapor pressure ay may kinalaman sa amount of vaporization. Mas mabilis mag-vaporize yung liquid, mas mabilis tataas yung vapor pressure, mas mabilis ma-reach ang same atmospheric pressure at mag-boil. So kung mababa, mahina yung intermolecular force, mabilis mag-vaporize, mag-escape from the liquid state yung mga molecules, mas mabilis mag-accumulate or tataas yung vapor pressure, mas mabilis ma-reach ang atmospheric pressure at mas mabilis magbo-boil ang liquid. So, among the three, water, ethyl alcohol, and ethyl ether, strongest ang IMF in water, and therefore, it requires highest amount of energy to boil. Ethyl ether requires the smallest amount of energy to reach the atmospheric pressure and boil. So, weakest attraction in ethyl ether, strongest attraction in water. So, highest boiling point for water, lowest boiling point for ethyl. Another property is volatility, ability of a liquid to readily vaporize at a fairly low temperature, for example, 20 degrees Celsius. So vapor pressure of ethyl ether is 442.2 torr. So ethyl ether is volatile. Vapor pressure of water is 17.5 torr. It's only moderately volatile, and mercury is non-volatile. Can we explain the following in terms of IMF? Ammonia has higher boiling point than methane. Ammonia is a polar molecule, and therefore the type of intermolecular force is dipole-dipole. Methane is nonpolar, and therefore dispersion. Dispersion is weaker than dipole-dipole. So boiling point has stronger IMF and therefore has higher boiling point, higher energy requirement to reach the same atmospheric pressure. Number 2, potassium chloride has higher melting point than iodine molecule. Since potassium chloride is ionic, it has a stronger intermolecular force than nonpolar iodine. So the stronger the intermolecular force, the higher the energy required to melt. So that accounts for the properties. What accounts for the properties of the liquids are the intermolecular forces. So that will be all for this lesson. Thank you for watching. Until next time.